Hey guys, welcome back. Today we'll be talking about inverse variation. Remember in my first video, I introduced the topic variation. I also told you that we have basically four types of variation: our direct variation, our inverse variation, our joint variation, and then the partial variation. Okay, so today we'll be talking about inverse variation. Unlike the direct variation, in which when a quantity increases, another the other quantity increases. In our variation, when one quantity increases, the other decreases. Okay, so today we'll talk about the inverse variation. Okay, inverse variation. All right, now if I say if I say that x varies inversely as y, now this is how I write it. X varies inversely as y. All right, x. All right, x varies. I'll use this my varies to symbol as 1 over y. So this is s varies inversely as y. So this means that when x increases, y decreases, and also when y increases, x increases. Okay. So if I have that a varies inversely as b, I'll write it this way. A varies inversely as b. So this is how we represent an inverse variation. Okay. Now, a real life example of an inverse variation is when you when your dad drives you to school. You can say that the speed is inversely proportional to the time taken to arrive at the school. So the speed of your dad's car is inversely proportional to the time taken. So it means that um, at a higher speed, you will get to the school faster, right? And at a lower speed, the time will increase. The time taken for you to get from your house, go from your house to the school will increase. And the same thing, um, when the time increases, it means that the speed reduces. And when the time reduces, it means that the speed increases. Okay, so that's our inverse variation. When one quantity increases, the other reduces. And when one reduces, the other increases. Okay, so it's the inverse. Now, next we're going to find, see how we can solve problems on inverse variation. Remember, I gave you steps. We'll still follow the steps that we use to solve problems in direct variation. Okay. So, I have a question here. Listen. Um, if x is inversely proportional to m square, right? If x is inversely proportional to m square, how do we write it? We'll say x is inversely proportional to 1 over m squared. Okay, so that's how I write it. This here says that x is inversely proportional to m squared. Okay, now we are given the following parameters. We say x is equals to 3 when m is equals to 9 in the question. So s x equals to 3 when m is equals to 9. All right, and we have to find x when m equals to 3. Find x when m is equals to 3. Now, there's a question. M is inversely proportional to m squared. When x is 3, m is 9. We want to find x when m is equals to 3. Okay. So how do we solve this? If you can remember the last video, I told you that the first thing we do is to change this our relation to an equation. Okay, change this by removing the we change this to an equation by removing the very two symbol and introducing a constant and an equal to sign. Okay, so let's do that. So let's call the constant k. So x is inversely proportional to m squared. So I can say that x, to change the variation symbol, I introduce a constant and an equal to sign. So I'll say x is equals to k times 1 over m squared. So x will be k all over m squared. Okay. Do you see that again? I introduce a constant and I introduce a constant and an equal to sign. So we now have what? An equation here. Now I told you that the next parameters, the next thing for us to do is to find the value of our constant and then write the relationship between x and m squared. Now we can do that by using the information or the parameters provided us in the question. So we were told that when x is 3, m is 9. Okay, so I'll put it in this equation. Okay, let's see if this will reach. Okay, now when x is 3, we have 3 is equals to um, m is 9. When x is 3, m is 9. So we have 2 is equals to k all over 9 squared. Of course, we know that 9 squared gives us 31. So we have that 3 is equals to k all over 81. Okay, so we have that. If we cross multiply or we clear fractions, we have that k is equals to 3 times 81, which gives us k is equals to 243. Okay, now what this tells us is that in place of, we'll go back to this equation for us to write the relationship between x and m squared. In place of k, I will write 243. Okay, so in place of k, I'm going to put down 243. So let's do that on another screen. Remember the equation x is equals to k over m squared. So it means that the relationship between x and m squared means that the relationship, so the relationship, so the will be relationship will be x equals to, what's the value of our k again? 240, yes, 243 all over m squared. Okay, now you can remember that the question, even though I cleaned it, said that we should find the value of x when m is equals to 3. Okay, find the value of x when m is equals to 3. Okay, so we'll have that when m is 3, so when m is 3, we'll have that x will be equals to 243 all over 3 square, which gives us 243 all over 9. Okay, now next we'll have that x is equals to, now 9 goes here 1, 9 goes here 2, remember 9 goes in there 24 2 times, that is 9 times 2 18, remember 6, then 9 will go in 63. How many times? 7 times. Okay. All right. So we'll have that x is equals to 27. All right. Now I'll give you more examples and then I will also explain there. Remember, I told you that anything written on green or typed using a green color shouldn't be in your notes, but you can write anything typed in black, red, and blue. All right. So have a nice day, guys.